Why do large engineering organizations struggle so much to deliver software? It's not the engineers, it's not the technology, it's the structure. And in this video, I'm going to break down the three biggest reasons and what you can do about it. I'm Patrick from Insightful Pause, a senior engineering professional with over 20 years in the software industry. I've worked in startups, scale-ups, and large enterprises, and I've seen these patterns play out everywhere. Here's a scenario. You're an engineering lead. You've got a clear roadmap, a motivated team, and a feature your customers are screaming for. You could probably build it in 6 weeks, but you can't start because you need a new data pipeline from the data team, and you're 14th on their backlog. You need a Kubernetes namespace from the platform team and their mid-migration. And the security team need to review your architecture before you write a single line of code. But their next review slot is 5 weeks away. Welcome to enterprise software delivery, where the org chart is the bottleneck, and nobody can figure out why everything takes so long. Before we get into the three problems, I need to introduce one idea that underpins everything I'm about to say. It's called Conway's Law, and it was first stated by Melvin Conway in 1967. Any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. In plain English, the software you build will mirror your org chart. If your organization is siloed, your systems will be siloed. If your teams can't communicate easily, your services won't integrate easily either. This isn't just a theory. If you've worked in a large organization, you've seen it. You can literally look at the architecture diagram and point at the org chart that produced it. And it's why organizational design isn't just an HR topic. It's an engineering topic. How you structure your teams directly determines how effectively you can deliver software. With that in mind, let's talk about the three big problems. Part one, capabilities versus value streams. The first and most fundamental problem is how large organizations structure their engineering teams. Most enterprises organize around capabilities. They build vertical teams aligned to technical functions, a data team, an infrastructure team, a governance team, a security team, a QA team. Each of these teams serves the entire organization, their shared services. On paper, this makes sense. It avoids duplication. It creates centers of expertise. It looks clean on an org chart, and a CFO loves it because it's efficient on headcount. In practice, it's a delivery disaster. Here's why. Let's say you're building a new product feature. You need some work from the data team, maybe a new event pipeline. You need infrastructure provisioned. You need a security review. Each of those teams has their own backlog, their own priorities, their own leadership, and their own capacity constraints. You don't control any of it. You raise a ticket, you make your case, and you wait. And you're not the only team waiting. Every product team in the company is competing for time from the same shared capability teams. So what happens? Your 6-week feature takes 6 months. Not because the work is hard, but because you spent most of that time blocked, waiting for other teams to get to your requests. Now compare that to how startups work. A startup has a small cross-functional team aligned to a value stream, meaning they own a slice of the product end to end. They have their own front-end engineer, their own back-end engineer, someone who can handle the data work, someone who can manage infrastructure. They're self-sufficient. They set their own priorities. They ship. The painful irony is that large organizations adopt the capability model specifically to be more efficient, and it makes them dramatically slower. You've centralized expertise, but you've also centralized bottlenecks. And here's the cultural side effect nobody talks about. When you're dependent on other teams and you can't influence their priorities, people start gaming the system. They inflate the urgency of requests. They escalate to leadership. They try to build things themselves to avoid the dependency. And that creates its own set of problems, which brings me to part two. Part two, adversarial organizations. When you organize into capability verticals, you inevitably end up with fuzzy boundaries, and fuzzy boundaries breed conflict. Let me give you an example. Say your company has a platform engineering team. Their job is to provide self-service access to cloud infrastructure, compute storage, networking, the works. They've been doing this for years. They've built tooling, they've built abstractions, they have a roadmap. Then the company decides AI is a strategic priority. So they spin up a new team, an AI platform team, whose job is to democratize access to LLMs, GPU compute, ML pipelines. Makes sense from a strategy perspective. But now you have two teams whose scope overlaps. The AI team needs infrastructure. Do they use the existing platform team's tooling? Do they build their own? Who owns the GPU clusters? Who decides which LLM provider to standardize on? Who controls the spend? What starts as a reasonable organisational decision turns into a turf war. Both teams feel ownership. Neither wants to be dependent on the other. Leadership hasn't clearly delineated where one team's responsibility ends and the other's begins, partly because with emerging technology, nobody's sure yet. And this isn't a one-off example. This pattern plays out everywhere in large organisations. The mobile team and the front-end team arguing over who owns the design system, the data engineering team and the analytics team both building transformation pipelines, the DevOps team and the SRE team with near identical mandates and completely different tooling. The result is duplicated effort, political tension, and engineers spending their energy navigating internal politics rather than building software. In the worst cases, teams actively block each other, refusing to support integrations, withholding access, competing for the same headcount budget. None of this happens because people are bad. It happens because the organisational structure creates misaligned incentives. When teams are measured on their own output rather than overall delivery, they optimise for their own domain. They protect their scope because their funding and headcount depend on it. Startups don't have this problem. Not because startup people are better, but because there's one team, one mission, and no ambiguity about who owns what. Part 3, the outsourcing trap. This one might be the most frustrating of the three, because the logic behind it sounds so reasonable and falls apart so completely in practice. Large organizations love outsourcing, and from a pure balance sheet perspective, it makes sense. Fewer full-time employees, lower fixed costs, workforce flexibility. Scale up when there's work, scale down when there isn't. If you're an accountant, it's beautiful. If you're actually trying to deliver software, it's a nightmare. Here's how it typically works. The company maintains a thin veneer of full-time employees, enough to hold institutional knowledge and manage vendors. Then when a new initiative kicks off, they engage a consultancy or a staffing firm to bring in contract engineers. The project finishes, the contractors leave, and you scale back down. Elastic workforce. Very neat on a spreadsheet. Now let's talk about what actually happens. First, procurement. Before a single contractor writes a line of code, you're dealing with legal reviews, contract negotiations, vendor onboarding, background checks. In a large enterprise, this process alone can take weeks, sometimes months. Then hardware. You need to provision and ship a laptop. If you're lucky, there's stock available. If you're not, there's a lead time. I've seen people wait 3 to 4 weeks for a machine. Then access. Internal systems, VPNs, code repositories, cloud environments, CI/CD pipelines. Each one requires an access request, often with separate approval chains. Some systems require additional security clearance. This isn't a morning's work, this is another week or two. So we're now potentially 2 months in, and your contractor hasn't written a line of code. Now the real clock starts. They need to learn your domain, your architecture, your code base, your conventions, your internal tooling, your deployment process, the weird quirks of your legacy systems that aren't documented anywhere. Depending on the complexity of your domain, this ramp-up period is anywhere from a few weeks to several months. And then, just when they're finally productive, genuinely contributing, understanding the context, their contract ends. They leave, and everything they learned walks out the door with them. The next contractor starts from zero. You're essentially paying for the same ramp-up cost over and over again, and you never build compounding knowledge in your teams. It's like filling a bathtub with the plug out. The companies that do this aren't stupid. They're optimizing for the wrong metric. They're minimizing headcount cost when they should be optimizing for delivery throughput and knowledge retention. And those two things require stability. People who stick around long enough to build deep context, who feel ownership over the product, who care about the long-term quality of the code base because they know they'll be maintaining it next year. How to fix it? Thinking like a startup at scale. So that's the diagnosis: capability silos, adversarial structures, and the outsourcing trap. 3 patterns that individually slow you down and together can make delivery grind to a halt. The question is, what do you actually do about it? You can't just restructure a 1,000-person engineering org overnight, and you can't pretend you're a startup when you have regulatory requirements, legacy systems, and a board to report to. But you can apply startup principles deliberately and strategically. Here's how. First, align teams to value streams, not technical capabilities. This is the single highest leverage change a large organization can make. Instead of a data team, an infrastructure team, and a front-end team that all serve everybody, create cross-functional teams that own a product or customer outcome end-to-end. Each team should be able to take a feature from idea to production without raising a ticket with another team. This is essentially the model described in the book Team Topologies by Matthew Skelton and Manuel Paes. Streamlined teams supported by enabling teams and a thin platform layer. If you haven't read it, it should be required reading. For anyone designing an engineering organization, you'll hear pushback on this, but we'll duplicate effort. And yes, you might have two teams that each have someone who knows Terraform, but the cost of that duplication is dramatically lower than the cost of the coordination overhead, the block backlogs, and the 6-month feature delivery cycles you're living with now. Optimize for flow, not for resource efficiency. Second, draw clear boundaries and make them explicit. Every team should have a clearly documented scope, what they own, what they don't, and where the interfaces are. This sounds obvious, but most large organizations simply don't do it. They assume people will figure it out. They won't. They'll fight about it instead. When two teams have overlapping scope, leadership needs to make a call and communicate it clearly. This isn't micromanagement. It's the bare minimum of organizational clarity. Third, invest in your platform as a product, not a mandate. If you need shared capabilities and at scale, you probably do for things like CI/CD, observability, and cloud infrastructure. Treat your platform as an internal product. The platform team's customers are your engineering teams. That means the platform needs to be self-service, well-documented, and genuinely useful. If teams are trying to route around your platform, that's feedback, not insubordination. The best internal platforms I've seen operate with the same discipline as an external SaaS product. They have roadmaps, they track adoption, they measure developer satisfaction, and they treat friction as a bug. Fourth, stop treating people as interchangeable resources. Build stable, long-lived teams, invest in their domain knowledge. Accept that onboarding takes time and that continuity has value. If you must use contractors, embed them in existing teams for meaningful durations, not 12-week rotations, and pair them with permanent staff who can maintain continuity. The goal is compounding knowledge. Every month a stable team works together. They get faster. They understand the code base better. They anticipate problems. They build shortcuts and conventions. Every time you churn the team, you reset that clock. And finally, measure what matters. If you measure teams on utilization and output, tickets closed, story points delivered, you'll get teams that optimize for looking busy. If you measure teams and outcomes, time to deliver a customer-facing feature, deployment frequency, lead time for changes, you'll get teams that optimize for actually shipping. The metrics you choose encode your values. Choose ones that reward flow, not activity. Okay, so there you have it. My ideas around why large organizations, a lot of the time, are not the most efficient at building software and how you can fix it. I hope this has been useful for you. If so, please like and subscribe, and I'll see you on the next one. Thanks again, and goodbye.